In the last video, we talked a little bit about the Dirac delta function. In this video, we want to see how we can take the Laplace transform of it. And here is our basic definition of the Laplace transform for a function f of t. We're taking the integral of f of t times e to the minus st dt with these limits on it. And as you saw in the previous videos, when we dealt quite extensively with the Laplace transform, it always gives us some function of s. Now, let's suppose then that our function f of t is the Dirac delta function, say t minus a. So that would be the integral from 0 to infinity, Dirac delta function of t minus a, e to the minus st dt. And this is always 0 except when t equals a. And we're doing it now for a positive value of a, so that a lies between 0 and infinity. So this is always going to be 0 except when t equals a. So this will be equal to e to the minus s times a. In our last video, we had established that when we have a situation like this, that this equals f of a. And the limits here could be from minus infinity to plus infinity, as we did in the previous video, or it could be from 0 to infinity, or it could even be a definite integral, providing that a lies in between g and h. So from this, then we get this. So the Laplace transform of the Dirac delta function is pretty straightforward once we realize this relationship, which we had established in the last video. So the Laplace transform of the Dirac delta function t minus a is e to the minus s times a. Now what if we have the Dirac delta function just of delta t? Then a is 0, so we'd have e to the 0, which is 1. So the Laplace transform of the Dirac delta function, without it being shifted, is simply 1. Now, from our definition, as you know from our previous videos, when you take the Laplace transform, you usually get a function of s, but not in this case. It's just simply 1. Now, the Laplace transform of 1 that is 1 over s. And of course, the inverse Laplace transform of 1 over s is 1. Now we have that the inverse Laplace transform of 1 is the Dirac delta function, taking the inverse Laplace transform of each side of the equation. Now, let's see if we can consider one more basic equation. Suppose we're interested in finding the Laplace transform of a function, say f of t, times the Dirac delta function, t minus a. So we use our definition, and that will be this times e to the minus st. Again, we're working with positive values of a, so a lies between 0 and infinity. This is always 0, except for that one instance when t equals a. So this will just give us f of a e to the minus sa. So we have that, let's write it over here, the Laplace transform of f of t this equals f of a e to the minus sa. So the Laplace transform of t minus a is e to the minus sa. If we multiply it by some function f of t, it's just f of a e to the minus sa. And the Laplace transform of just delta t, that equals 1. So those are the basic equations that we wanted to take a few minutes and derive in this video. Why don't we could work with some examples, but let's do this. Let's summarize the basic equations now involving the Dirac delta function that we have discussed both in this video and as well in the previous video when we introduced the Dirac delta function. So we had this from the last video, and when we did that we were summing from minus infinity to plus infinity. But again, it can be a definite integral, say going from g to h, providing that a lies in between there so that we're sure to sum over a. And in the last video, we had established that f of t that was f of a, and we were summing from minus infinity to plus infinity, or again it could be a definite integral like this, providing that a lies in between g and h. And then for the Laplace transform, we just derived that the Laplace transform of that is e to the minus as, and if it's just delta t, then the Laplace transform is 1. And then finally we had that the Laplace transform of a function times this Dirac delta function is some constant, f of a, times e to the minus as. So here are 1, 2, 3, 4, 5 basic equations involving the Dirac delta function and LaPlace transform properties of it. I think in the next video we'll just try to work some examples here using these different formulas. A reminder that the playlist for the differential equations is featured at the website at digital-university.org.